Today we will be talking about factored form of a parabola. There's two ways to write factored form of a parabola. There's the simple form where you just have x minus b in parentheses, b being a constant, and x minus some other constant in another set of parentheses, and you might have some number multiplied outside those parentheses. There's also what you might call distributed form, where you have inside parentheses some constant multiplied by x minus another constant, and another constant multiplied by x minus another constant. We'll compare these forms and think about what they look like on a graph and why they match up with the graph the way they do. Let's look at this graph. We right now have a graph of the simple form of the parabola, the x minus b and the x minus d. And you'll notice we have set b equal to 2 and d equal to -1. Let's look at what that produces on the graph. Of course, we have the parabola shape, and we might notice what are some critical points, 2 and -1. What were the values that we set b and d to? b was set to 2, d was set to -1. Notice that the numbers inside the parentheses are the same as the x-axis, the x-intercepts on the graph. Can we make sense out of why the x-intercepts are the same as the numbers we see in the equation? Let's think about that for a minute. Before we go back and look at the equation, think about what the x-intercept implies. What are the y values at the x-intercepts? Let's write it in so you can see it. If I set y equals to 0, you'll notice the 0 line is the x-intercept line. So to say the x-intercepts is the same as to say that in this equation, f of x, that is to say y, is equal to 0. So let's think about what that means in terms of the equation. So looking back at the equation, what we thought about is the idea that y is going to be 0. Everything else is going to be the same. Let's write the equation we were just looking at and think about what's going on there. We had b is 1 and d is -2. I think that's what it was. We can switch it up if we want. Look at this and think about what is really happening. If something times something is equal to 0, what will either of those things be? Well, think about how that could occur. That could occur if we had 0 times something. Let's call that t for clarity. Or it could be if we had something times 0. Let's call that s just for clarity. So it doesn't matter what the first thing is. If the second thing's 0, you're going to get 0. And it doesn't matter what the second thing is. If the first thing is 0, you're going to get 0. So the 0 property tells us that if we multiply things together and get 0, one of those things has to be 0. So what does that imply about the parentheses? Well, if I have x minus 1 equals 0, little quick thinking, x had to be -1. If I have x minus -2 is equal to 0, that's the same as saying x plus 2. Think of your negative properties. In that case, the only thing that's going to work is x equals -2. So we know that if we have 0 as our answer, one of these two things has to be 0. That makes the -1, x minus 1. I wrote that backwards, didn't I? X minus 1, x would have to be the positive 1, wouldn't it? Plus 1 minus 1 equals 0. So x would have to be positive 1, and for the other section, x would have to be -2. So we know that these 2 points exist. For this problem, where there's a 1 and a -2, let's go back and check that on our graph. Now remember, the idea we're working with is that the y-intercept implies that y is equal to 0. The x-intercept implies y is equal to 0. And if we match that to the quadratic using the 0 property, this point is going to be what's inside the one parentheses. This point's going to be what's inside the other parentheses. So the -2 corresponds to x minus -2, and the +1 corresponds to x minus +1. So we're looking at this possibility, and it doesn't matter what we change our numbers to. We're going to see that idea. What if I change a to -5? Well, a is outside the parentheses. It doesn't change anything. So let's change that back and say, what if I change the b to a -3? When b is -3, we can see a point has to change to -3. If d is, say, 4, you can see the point changes to 4. What's happening is it always has to match what's inside the parentheses, and that is because, as we saw here, zero property, either the first set of parentheses is equal to 0 or the second set of parentheses is equal to 0. How do we know that? Because on the x-axis, y is equal to 0. Now, let's look at the other form, the distributed form. We're going to use the same reasoning, and we're going to ask ourselves, on the x-axis, y is equal to 0. So, if y is equal to 0, either this piece has to be 0. We could write that out. Ax minus b has to be equal to 0. Or the other piece has to be equal to 0. Cx minus d equals 0. For the same reason, if two things are multiplied together, give you 0, either the one is equal to 0 or the other one is equal to 0. Well, with a little bit of equation solving, we can say the first set of parentheses says x has to be either b over a, and the second set of parentheses says x has to be d over c. So this time we get a fraction. A thing multiplied turns into a denominator when we solve for both parts. Let's look at how that's going to affect our graph. Now on our graph, we have a equals 1 and b equals -3. Well, think about the fraction we just mentioned. And we wrote it in here. B divided by a, -3 divided by 1 is -3. D divided by c, 4 divided by 1, that's going to be 4. Well, let's check out what happens. What happens if I change c to 3? I now have 4 divided by 3. Do you recognize that as 1.3 repeating when you write it as a decimal? Let's look at this example. Let's put change a to 5. -3 divided by 5. Do you recognize that turned into a decimal as -0.6? Okay, there it is. Our multipliers turn into denominators, and the thing being subtracted turn into the numerator. And again, that's easy to show, as we already did. When you solve each piece, minus b gets added the other side for positive b, then you divide by the a. Same thing for the c and the d. So on our graph, we can see the relationship exists right there, and we can pick any denominator we want, and that's going to work for the same reason. So our goal was to figure out, why does factored form of a parabola work on the graph the way it does? The reason it does is the zero property, and the reason the zero property works is on the x-axis, y is equal to 0. So either the one factor has to be 0 or the other factor has to be 0. Doesn't matter which form you use, either the first factor has to be 0 or the second factor has to be 0. And what simple curve would go through the different zeros? Right there, we're looking at our example. This nice simple parabola is going to go through both of those zeros. So that's the idea. We get a parabola going through the x-axis twice because we got two factors, both of which correspond to a 0, the 0 being the x-axis.